Assalamu alaikum everyone. This is Dr. Hassam Anjum Mir. I'm a consultant prosthodontist, assistant professor in Foundation University College of Dentistry. I'm a graduate of Army Medical College and I did my post graduation from Armed Forces Institute of Dentistry. And being there, I used the CAD-CAM machinery available there, which is the best available in Pakistan of Serona CAD-CAM machine. So that's why I'm giving this lecture on CAD-CAM dentistry to educate the younger generation and my colleagues on using the chair-side digital CAD-CAM technique. We are using the CAD-CAM technique, but it's laboratory-based. We just do the preparation, take the impressions, send into lab, and the lab then designs the and fabricates the crown. But the chair-side CAD-CAM is available at one or two places in the Pakistan, and I was a pioneer of chair-side CAD-CAM dentistry in FID. I conducted a first workshop in 2017 where I presented the cases and gave a live demonstration with my colleague Major Imran on CAD-CAM dentistry in the auditorium. And then I went on to present this CAD-CAM dentistry and digital smile design in fifth PPA conference in that happened in Koita in 2018. So that's why I'm giving this lecture, so to educate you, then so you can know the flow of the CAD-CAM, because this is an emerging technology and Pakistan is lagging much far behind in this. The world has adopted it as a norm many years ago. So I also have a YouTube channel by the name of Aesthetic Dentistry Center, the name of my clinic as well. You can search this channel by looking at searching my name or the titles of some of my YouTube videos. In this channel, I guide my colleagues in younger generation on how to open your own dental clinic, as well as how the PG trainees on how to write a synopsis, and also how to appear in part one and part two examination. So this is a new channel. I have a few videos on it, and I'm going to add up more videos, so you can subscribe to the channel and get educated as well. So this is the outline of my presentation. First of all, I'm going to show you the flow of the CAD-CAM dentistry using a case presentation, and then there will be introduction, material and prosthesis, and in the last, digital smile design. So you can see in this picture that I have prepared an inlay for an all ceramic prosthesis. You can see in this picture that I've prepared it. So now after the preparation is done, we are going to start with the CAD-CAM procedure. First of all, on the software, there are multiple companies available for CAD-CAM as well as softwares that are available. The one I am using is of Serona Dent Supply, because I had access to this software. So, but the process of the CAD-CAM dentistry is same regardless any software you are using. As you can see in this picture, we select the tooth number as well as we select the type of processes that we are going to fabricate. Then we apply this anti-glare spray on the teeth. Because the CAD-CAM was of an older version, it required this anti-glare screen. But the latest intraoral scanners do not require this. They can even scan the tooth when it is wet. But we applied this. You can see that we are using the intraoral scanner. You can see the blue light, which means that it is working and recording the occlusal surfaces. This is a short video where you can see that how a digital model is created on the basis of that scanning. Although this is of another system, CareStream 3600, and the scanning was done for the purpose of clear aligners, but I have added this video just to show you that how scanning is done and how a digital model is created. So these are the digital models of the prosthesis that I'm going to fabricate. You can see on the left hand side, there is the tooth which was prepared and the opposing tooth. So first of all, the procedure for designing a prosthesis is that we demarcate the margins. And you can see in this picture The blue outline is available. This is the where I have demarcated the margin to tell the software that they should keep the margins at this place. So this is the design processes. The software automatically gives you the proposed design. The proposed design is not always 100% correct. You have to make some adjustments to make it 100%. The blue color on the occlusal surface shows the strength of the occlusal context. Red means high, and this blue color, dark blue color, means adequate contact strength. So after that, we send the command to the milling unit, and you can see this is a block with a screw on it. And the this is the block of a ceramic which we put it in the milling machine, and on this software we decide where the prosthesis is. You can see I have put the prosthesis on the end of the block. In this way, we can if a smaller prosthesis is being fabricated, we can fabricate more than one prosthesis from the same block. If I had placed the block, this prosthesis in the center of the block would not have been used for a second prosthesis, one, and second, increased time due to grinding of the end of the block. As you can see in this zoomed in picture, it only takes 7 minutes and 22 seconds for fabrication of this prosthesis. Whereas in the laboratory, it would have taken a whole day to fabricate this, because you have to fabricate the models, then from the models you fabricate wax pattern, then the wax pattern is invested. After that, burnout, it is placed in burnout furnace where the wax is evaporated. Then you place it in the ceramic furnace where the ceramic is, and after that you have to finish the ceramic prosthesis, because there will be flashes and extra screw attached to it, and it would have taken nearly whole day. Whereas in this machine, 7 minutes and 22 seconds only. So this is the advantage of CAD-CAM dentistry. And when you have a chairside CAD-CAM, you can provide the patient with the processes within the same appointment. Within 1 hour to 2 hours, you can prepare. The patient is waiting in the waiting room. You do this stuff, and when the process is ready, you can cement it in the same. So no need for multiple visits, no need for placing temporary restorations during that time. So this is the picture of the milling unit. You can see on the both sides, these are mandrels on which burrs are attached, and in the center, the block is attached. This is the video of the processes. You can hear the sound, and you can see how it is working to create the prosthesis. So after milling, you can see this prosthesis. This prosthesis is in purple color. Why? Because it is partially fired. The ceramic is purplish to pink color when it is not fired, and when it is fired in the furnace, it turns into the color which you have selected. So, but that the conventional ceramic is available in powder form. But in this, because of partial firing, it is in solid form, so that it can be milled out. So after firing, you can see the color of the prosthesis have been achieved. So this is the prosthesis after cementation into the mouth. You can see it is blending with the surrounding tooth color very good, and you cannot differentiate between the prosthesis and the natural tooth color. So this is another case just to show you a different workflow. You can see I've prepared a molar crown. You can see from this lateral view the adequate clearance, because all ceramic crown requires at least 2 mm of occlusal clearance, and supragingival margins, because there is no metal border around like it is in the PFM crown. So you can prepare a supragingival margin. Supragingival margins are more healthy for the gingiva. So this is the another workflow that you can use the intraoral scanner to scan the model as well. So you can use this as an extraoral scanner for 1 to 3 unit bridge prosthesis as well. So sometimes it is difficult to scan intraorally because of the saliva and excess limited mouth opening of the patient. So you can use this method as well. So same demarcating of the margins, and then the uh, prosthesis is given which we adjust the occlusal context, and this is the molar crown intraorally. You can see in this picture You can see a slight difference in color because the gingival, the cervical portion of the tooth had yellowish staining, but it is a molar tooth, and we don't. This part is not shown during smile, so it's okay. This part is camouflaged. So, introduction to the CAD-CAM dentistry. CAD-CAM dentistry system utilizes a process chain consisting of scanning, designing, and milling phases. All three phases have been shown you with the case. So Dr. Duret was the first person to develop dental CAD-CAM in 1971. Then Dr. Mormon developed the CEREC system in 1986. The CEREC system is what is present in the Sirona CAD-CAM. And then other systems like Procera, Lava, Zircon, Kevo, and many other were developed later on. So just to give you an example, in-office system, CEREC is a very good in-office system with intraoral scanner and intraoral and chair-side milling machine. Then dental laboratory models, CEREC has an in-lab model as well, Lava, DentiCAD, and then outsourcing system, that is Procera. Procera means that the CAD-CAM is present in the company's own warehouses. So what you do is that you have an intraoral scanner available at your clinic. You scan the tooth and send the scan data to the company. They will design it in the warehouse, they will mill it, and then they will ship the crown to you at your clinical address. So the CAD-CAM of Procera, the machine is not available for commercial purchase. So again, just summarizing the workflow, the in the conventional process, you the intraoral abutment, you take the impression, then model is made, then you do a wax up, then casting is done, then porcelain is applied, and final restoration is created. Whereas in the digital model, you do the optical impression, virtual model and virtual wax-up is used during the software. That is the CAD part of the CAD-CAM, computer aided designing. And then comes the milling part, that is computer aided milling. That is done in a milling machine and final restoration is created. So the steps are decreased as well as the time is decreased. So this was the CAD-CAM system that was I was using. CEREC AC is the acquisition center. This is the place where the software is present as well as the intraoral scanner is present. And this was the milling machine in lab MCXL. This is a chair side, very compact, small milling machine. You can fit on a simple table. These are the other few of the other companies that are available. Shining 3D is a very cheap, comparatively cheap Chinese company, and it has good results. Otherwise, other Zircon, Zion, ExoCAD, 3Shape, other companies are also available. So what is the advantages? First is prosthesis is ready in 1 to 2 hours. No multiple visits are required. Preparation can be viewed on the software and you can perform the modification again and scan it again. You can adjust the occlusal contacts, proximal contacts, marginal field, everything on the software. So there is very minimum chair side adjustment. And the articulator is built in as well, so you don't have to articulate the models conventionally and then scan it. You can add the values of the articulator on the software and it automatically adjusts your bite accordingly. So disadvantages, these are the disadvantages which has led to its less use in Pakistan. One is that machinery is very expensive because it is for multiple reasons. One, it is the latest technology, so it is expensive. Secondly, because of the shipping charges as well as tax, which comes with the import of this machinery, it becomes very expensive, and it is difficult for simple clinics to own it. Dental laboratories or institutes have the budget to purchase this equipment. Special technical knowledge, you need special software for special courses to learn the software as well as for maintenance of the machine. Fabrication is expensive, the ceramic is expensive, so per unit crown cost in the laboratory is expensive. And other are for minor which can be managed, like scanning subgingival margins is difficult, which you can do by taking a conventional impression using retraction cord and then scanning the impression or the cast made from that impression. Some materials require laboratory process, like I showed you in the first case that we need a laboratory process. For that, you need a furnace. Chair side furnaces are also available, so you will have to purchase that in addition to the CAD-CAM system. And the materials are difficult to adjust, like zirconia. Zirconia is very hard, and adjustment of occlusal contacts or proximal contacts is a bit difficult. So the materials, all types of materials can be used for this purposes. For example, ceramics, the ceramics, lucite base, feldspathic, lithium silicate, zirconia modified lithium silicate, and composite materials, in which there is composite as well as blending of ceramic, which are called hybrid materials as well. For example, like Colteen's Brilliant Cryos is an example of that material. Shofu's material is also available, which is in this form. You can mill metal as well. In metal, you can mill cobalt chromium, nickel chromium, as well as titanium. Resins are available for fabricating wax patterns as well as temporary crowns. Wax blocks are also available for fabrication of wax pattern. For example, if you want to mill an all metal crown or core of a metal ceramic crown, so you can mill the design using the wax block, and then using the conventional casting method, you can create the metal part, all metal crown as well as core of the PFM crowns. So the types of processes by this software as well as all the other software and milling machine is crowns, partial coverage crowns, inlays, onlays, fixed dental processes, copings, veneers, even implant abutments, implant supported crowns, custom attachments. As you can see in this picture, the attachment is milled for cast partial denture, implant frameworks of titanium, wax patterns for the crowns, acrylic stands for placing implants. You can mill acrylic complete dentures as well. There are multiple ways to mill that as well. One is like in this picture, you can see that the base plate is milled with the place for the teeth, and then you can mill the teeth separately using the same design as you can see in this picture, so that the teeth fit in perfectly into the indentations of the teeth on this base plate. And you can mill orthodontic appliances as well. So the new technology is 3D printing. It is not exactly CAD-CAM, but it is a part of the digital dentistry. 3D printing allows you to mill undercuts as well as the wax patterns in a faster and much easier way. And 3D printers are much cheaper as well comparatively. They are like 10% of the price of the CAD-CAM machine. Yes, you will need to use the CAD-CAM software, but you can send the message to the milling machine where you can print metal. Although the 3D printer which prints metal is very expensive and is used on industrial, but the acrylic and wax is the chair side 3D printer is available which can use these material. So you can, as you can see in this picture, you can print the wax pattern of the cast partial denture, which can then be cast using the conventional process. This is the 3D printing of the model. This is a stereolithographic model which was made for the purpose of fabricating this orthodontic appliance. And then the clasps are made using the conventional wire bending. They are placed on this model, and the model is again inserted into the 3D machine, and the acrylic part is then milled by 3D printed by the machine on this model. So just the clasps are made by hand. Otherwise, the model as well as the base plate of this orthodontic appliance is made by 3D printing. So now the CAD-CAM dentistry part is complete. We'll proceed with the uh, digital dentistry part now. So, digital smile design part using the CAD-CAM dentistry. I'll show you a case, and with that case, I'll show you how we plan this part. So, let me start the presentation. So, The purpose of the digital smile design is that you can design the smile of the patient which requires all the anterior crowns or veneers. So we can design them digitally and show that digital picture to the patient so that the patient can easily uh, see that how his prosthesis is going to look, and with that he can uh, uh, make a decision with you that how the process is going to look and how he'll be able to see his processes. So it strengthens the diagnostic vision as well as it saves the time, because in the conventional smile design, you had to take pictures of the patient as well as take impressions, then send it to the laboratory. The laboratory technician used to make the wax pattern of the designed proposed prosthesis, and that wax pattern is then shown to the patient, and the wax pattern does not has that good quality impact. Why? Because the wax pattern is in either white color or blue color, whereas in this picture you can select the shade of the tooth that you are going to provide to the patient, so which helps the patient to see how his color of his teeth is going to look, one. And secondly, you can modify the shape of the teeth on the software very easily, whereas modification of the uh, is very difficult on the uh, wax patterns. So this allows us to make have a good impact on the patient. So these are multiple softwares that are available for designing a digital smile design: DSD software, ExoCAD, Visit Smile, Plan Mecha, or the picture that you're seeing in the center is the built-in smile design software of the Sirona CAD-CAM, which I was using. So multiple softwares are devising this DST software is, and now ExoCAD as well is available in your mobile phones as well. So you can download as an app and then design the processes on the app as well. And one tip for the dentist is that although this whole CAD-CAM process is expensive, but you can buy this standalone digital smile design software. It is not very expensive. For any anterior prosthesis, you take the pictures of the patient and place those pictures in the software and design the prosthesis and show it to the patient how he wants the look of his teeth. When he agrees, you can send that digital file to the laboratory, and they will use that software to mill the processes accordingly to the design that you have finalized. So it can strengthen your treatment planning process and build a good rapport with the patient. And you can do that on your mobile or easily on a laptop. So I am going to show you a video of a digital smile design process. So we record the occlusion of the patient as well. So this is the preparation. This is the 3D model of the patient. We have made full arch 3D model. So we select the points. So model alignment within the arch. You can see we have taken the picture and the picture is converted into a 3D model, and you can adjust the teeth according to the aesthetics. So when the design is finalized, we show it to the patient. We can verify the occlusion as well. We can see the occlusion according to the patient's face as well. Consultation with the patient, milling of the prosthesis, and the results. So this is, you can see the timeline in this photo as well, that we started the procedure on Tuesday, and we completed the procedure on Wednesday. Because there were multiple preparations and multiple veneer fabrications, so it takes longer time. So it took us one day. On one day, we prepared the teeth, we took the scans, and we fabricated the veneers. And on the next day, we cemented the veneers on the patient. And don't worry, I'm showing you the pictures of the patient because we have taken consent from the patient. And this presentation was also presented in the PPA conference. So this is another case, and again we have the consent from the patient to show his photos. This is a patient who had componeers, that are composite veneers, 2 to 3 years ago, before presenting to us, and they were now discolored as composite discolors with time, and they were chipped off as well in some places. You can see in this picture they have turned slightly yellowish and they are chipped off in some places as well. So we prepared these veneers, you can see in the below picture, and they are made with hybrid shofu bite blocks. So the color of the prosthesis was whitened because the patient wanted a whiter smile. And secondly, the advantage of this ceramic veneers is that they don't discolor over time. So that is the best advantage. They don't wear out, they don't discolor. Whereas the composite veneers will discolor over time as well as wear out. This is another case. A patient was an MBBS doctor, and she had her marriage ceremony in 1 week's time. And she is suffering from, as you can see, she has an open bite as well as she is suffering from fluorosis. So this is after preparation. You may have a question in your mind that we are providing veneers on the fluorosed teeth, whereas the veneers required good bonding with the enamel, whereas the fluorosed enamel does not provide good bonding. But most of the fluorosis, as you can see in this picture, once the grinding is done, the shading, the discoloration of the fluorosis is not seen much on these teeth, because most of the fluorosed enamel is present on the superficial 100 micrometer of the tooth. So in this case, we are preparing 0.5 millimeter tooth, which automatically removes that maximum fluorosed layer. So the bonding of the veneers becomes good. So this is after cementation of the veneers. We, in this case, we have used brilliant Cryos hybrid blocks. We have increased the incisal length slightly as well to correct the open bite slightly as well. So thank you very much. This was the presentation showing you the digital smile design. Uh, I've explained the basic CAD-CAM process as well as the digital smile design as well. So now the main thing that I want to talk to you about is how you can incorporate digital dentistry in your clinic. I know that it is very expensive and not cost effective to buy this digital CAD-CAM on your own, but the ways in which you can incorporate digital dentistry is by making prostheses which are made by CAD-CAM, like EMAX all ceramic crowns, zirconia crowns, rather than metal ceramic crowns. Secondly, you can also make all metal crowns on CAD-CAM or using 3D printing. So you can tell the lab that the all metal crown that you are providing to the patient, they should fabricate it on CAD-CAM so that it has better marginal fit and better occlusal anatomy. The next way that you can do is by doing digital smile design, which I've already told you that you can buy the standalone rather than buying the whole CAD-CAM software, which will be expensive and difficult to use. You can buy the digital smile design part only, or the software which are only digital smile design. So you can download those softwares and design the prosthesis in your mobile or laptop, the anterior crowns, and then show it to the patient and then send that to the laboratory so they can fabricate that accordingly. And the third way is that you can visit the laboratory yourself. For example, if you do a case of veneers, you take the impression, send into the laboratory, they will fabricate the prosthesis, the anterior prosthesis with a digital smile design. You can get the smile design from the laboratory and show it to the patient. Once the patient approves, you can go to the laboratory yourself, make all the modifications that you think are required, and then get it fabricated in front of you, so that you know the how the process is going place, and you can guide. If you have the knowledge, you can guide the technician as well, because most of the technicians in Pakistan have do not have the proper course. Most of them have just trained from learning from their supervisor, so they don't know the nitty gritties of the designing as well as the occlusion or the proximal contact. They most commonly use the proposed design proposed by the software and just mill it accordingly. But whereas in my experience, as well as what I know, uh, from designing it myself and reading the articles online literature review, that you have to modify the design, you have to make the contacts tighter, you have to adjust the occlusion accordingly, because the software just gives you a proposed design, and it does not mean that the proposed design is the ideal. So these are the ways that you can incorporate digital dentistry in your practice. So, thank you very much for listening to my lecture. So, if you have any questions, you can ask those questions, and I will be more than happy to answer them to you. And also, thank you, the Dentoscope Academy, for inviting me to deliver this lecture on their YouTube channel. I have a very good relationship with them, and I provide also do the hands-on sessions in their academy of different courses. So you can join their courses as well for different purposes that you wish, and you can meet me there as well. Thank you. So if anyone has any question, you can write it in the chat, and I will be willing to answer them as well.